Okay. So everybody's doing the test circuit individually. That means that you will have to, you can hook it up with your partner, but you each will make your own circuit and you will each upload it to the PLD and make sure that your build circuit actually works the way it's supposed to. These things are really temperamental. I've had issues with these things not connecting to the computers. And then so you have to move to a different computer to make this happen. So just, you got to kind of bear with me. It's not ideal, right? If we had fully functioning stuff here and really great support, this wouldn't be a problem, but we have none of that stuff. So we're just kind of going with what we got. I'm going to post this. It has both the test circuit and fireplace PLD stuff. Now the fireplace, you should have already built that and simulated it. If you haven't, you have no business doing any of this stuff yet. But it's going to be very similar. So I'm just going to go through the process of making an OR gate circuit. The test circuit is an OR gate circuit. Okay, now you do need this. This is the diagram that shows our programmable logic device. And so I'll show you what it looks like on the screen in a second. But there's a bunch of digital input outputs on both sides, as well as some analog stuff, a power and ground. So this can be powered and grounded without the USB connection. This is the USB connector, and then these are PMOD links down here, which we're not going to use any of that stuff. It's more input and output stuff. But we're going to stick with these pins on the side, these yellow boxes. And not all of them get used, and some of them are specific. So yeah, there's a lot to this. But it's easy to understand once you start doing PLD files. All right, so we will come back to this. We're going to reference this because I'm going to use, I think, pins 21, 22, and 17, I think, to make this circuit. So I need 2 inputs and an output, so that's what that's going to look like. Now this is what it looks like sitting on the board. Now this is kind of at a strange angle, I understand that, but this is the top of the board with the digital inputs, the switches, buttons, LEDs are right here, okay? We also have our 7-segment display stuff, which we'll be eventually using, and then power and ground systems are up here. Now what's cool about it is that when it's plugged in to the system here, it doesn't need to be powered. So you can already see that it has a red power light, that's that there, and a yellow LED indicating that the chip is functional, meaning that it can be programmed. Down here is the PMOD box that's got all the PMOD junctions on it, and then this would be the top where I had showed you. Those are the connections. So you look real carefully here, you can kind of see these like little silver dots where my finger is. There's some down here as well. Now I have this sort of angled because I want to show you where I'm plugging the wires in. Literally, you plug this chip in, you set it up, and there are 3 wires for this activity. Super simple, okay? When you do the fireplace, there are 6 wires. That's it. All of the hard work is done by the machine, and it still works. So you can still actually make a functioning circuit. So anyway, without further ado, let's look at how this is supposed to work. So this is what you're going to end up building right here. It's an OR gate circuit. I'm going to close this one down, and we're going to start from scratch so you can see how this is supposed to work. So I'm going to go to File, New, and instead of doing a blank one, I'm going to do a PLD. That's what this thing is here with this kind of what looks like a electronic component on the page. So I'm just going to double click that. Now, things you need to make sure of. Number 1, when it says configuration, it needs to be a Digilent PLTW S7. We don't have S6s anymore. They've been replaced with the S7. Everybody has an S7. Click Next. That's good. Change that. Don't use that. That's a generic start point for all of the projects. Just call it practice. Everybody can call it practice. Say Next. Uncheck all. In this part of the wizard, we uncheck all, and then we click Finish. Now that's going to bring us to a screen that looks exactly like a simulation screen, but it is not a simulation screen. Everything you put on here is real functioning stuff on the actual chip. Okay, so it's a little different in terms of where you find components and what is available. But the hooking up part where you hook the wires up, that has not changed. So we're going to just click this button here. This is in the upper left corner, input connectors. And what it does is it shows us what is available on this device that can be acting as an input. So there are several PIO connections, as well as you could use the PMOD junctions as well. But again, we're not. There's no reason to use them for this particular setup. We're going to stick with PIO 21. I'm going to click OK. That's going to plop down right there. Let me zoom in so you can see it a little bit closer what this thing looks like. And then I also need to do one more input, and that's going to be the next one in line. Notice 2021 has disappeared. Those of you that are really up close there. Okay, 22 is available though, so I'm going to act on that and put that down. Those are my two inputs. Now, if you were simming, you would use the digital interactive constant. Okay, but in this case, these are actual connections to this circuit. Now we're going to go ahead and place the gate. So we're using an OR gate here, place component, and that is no different. And if you scroll down, this is where it starts. Scroll all the way down until you see OR, and you want to do the OR 2. Now these numbers stand for the number of inputs, so check this out. You can have a 3 input, you can have an 8 input, okay? That's what actually exists in the real world, number of inputs per gate. So yeah, that's a real time saver. If you've got a circuit, right, and you need 8 inputs for an OR, there you go. Now we're just using a 2 input, so we're going to go back to that, click OK, place the gate. So again, that's very similar to sim, and we're going to close that. Now we need to have an output connection also, right? So now next to that is a little square that says output connector. You click that. These are the available output connectors. So we do have some digital stuff. We will talk about that. That's not useful. The LEDs, we could do a built-up one inside the chip. We're not going to do that. We're going to go a little bit of an extra distance here, and we're going to use PIO 17. It's in that same block of connectors, right? We're going to click OK and then drop that on the screen. Now, you've got all the input and output connectors. Next thing you need to do is simply connect with wire. No different than the simulation when you're building a regular circuit. This is what we're going to do here. Same red wire that you typically would see. Now, you don't need to save this. This is just a demonstration for me to come along and say, okay, I can see that, yep, we can hit the switches, and in fact, this does work the way it's supposed to. So you don't need to save this particular file. But you do need to upload it, so this is the next step. Of course, in order for this to successfully upload, you got to have the USB cord plugged in, and you should have it powered up, and the ready light should be on. If those two things aren't happening, we got problems. We got to figure out what the situation is with that. But before we upload it, just to make sure that the microchip is happy, because sometimes it gets a little weird with when you plug stuff into it, we're going to hook up the wires ahead of time. All right. So let me make this big. I have the actual things memorized, but actually don't know where they are on the board. So excuse me for a second while I just familiarize myself. Okay, so there's 21 and 22. Now it doesn't really matter how those are hooked up to the switches. We're going to hook them up to switches, but those are our inputs right there. Okay. And again, if you're kind of far away right now, you're not going to see this, but you want to go back and just watch the video. There are little blocks here, little plastic black blocks here underneath the chip. Those represent the actual connections to the board. So again, 21 and 22. This is 24, that's 23, there's 22 and 21. So basically, I'm going to run some wire from there, and I'm going to hook those up to my switch access point here. The switches are down at the bottom of the board, okay? But these are going to act, they're going to send a signal into the chip, and then the chip will send a signal out to an LED. So let me grab some wire here. I got some at my desk. I'm going to just go ahead and plug those in. That's 24, 23, there's 22. So I'm plugging one wire into the 22 pin connection. And I'm going to use this different color here. And let's use something that's a little brighter. Use that one. And then this wire here is going to go into pin 21. Okay, so they're right next to each other, 21 and 22. And again, it corresponds to what's on the chip here. And those are just going to go into switches 0 and switch 1. All right. Okay, so that's where those go. Switch 0, switch 1 goes to 21 and 22. Now my output is 17. So I'm going to go back because I don't remember exactly which one is. I think it's from this side. I think it's 1 over, but I could be wrong. So I'm just going to verify. Actually, it is 1 over from the outside block. So I'll go back to that, and I'll plug in. That will be my output, and that's going to go to any one of these LEDs. There are, just so everybody's aware here, you can see there are 2 red, there are 4 yellow, and there are 2 green LEDs. So you have a large selection of LEDs to which you can plug into. I don't care, pick a color. Doesn't matter to me. I'm not particular about whatever color you want to use. They're all going to do the same thing. And by the way, each one of these has dual connection points. So you can see here there are 2 pickup points for the red 1 LED. There are 2 for the red 0, and so on and so forth. So you can use multiple outputs here. But again, we're just doing 1 wire, and that's going to go from pin 17 to whatever LED I decide to choose from. So let me look at the side of the block here. There we go, that's 17. Plugging that into 17. All right, and then I'm going to just plug it into green. Green 0. Just like that. So I got my 3 wires. I got 2 inputs. I got 1 output wire. It goes from pin 17 over to LED green 0 or G0. So there you go. That's it. That's all you have to do for this circuit. There's no powering up chips. There's no power and ground for this particular one. Just the 2 inputs and the 2 outputs. All right, so now I got to go back to multisim. Not done yet. Not done yet. Got to send this to the actual chip, and we'll see if it works, okay? Sometimes, a lot of times, it doesn't always work the first time. So we're going to go to transfer, export to PLD, okay? And you're just going to click next. And then this should already be set up. If it's not working on your machine, you're going to have to go to one that does work. Because if I'm not mistaken, I don't know if the tech set these all up to work with our S7 chips, okay? So all this is telling me is where's the file going, what type of tool is it using, Xilinx Vivado, Design Suite 2023 to 64-bit, unsupported. I have no idea what that means. And it also has some advanced settings here. Where did the constraint files come from? That should have been set up by our computer tech. And does it allow unmatched lock constraints? Should be yes. If that stuff looks good, great, okay? Oh, by the way, the part number is right here. It's an XC7S25. We're going to click Finish, and then this is going to take forever. Oh, by the way, yes, just click Yes. Just click Yes. This usually takes forever, and it's unfortunate, okay? So what it's doing is, first of all, it's checking to see, do I have a connection to the device? You can see up here, if you look real carefully, there's some 1s and 0s kind of dancing around next to this little circuit here. And then it quickly jumps to step 3, and everybody's like, wow, this is going really fast. No, usually this is where it takes forever. And it used to be worse. When I first started teaching this, it took an extraordinary amount of time to program our S6 chips. We didn't even have it built in. So what you did was you built your circuit, you had to save it, then you opened your circuit in another program and you made sure that that was connected, and then that program would connect it. Now it's all in one, okay? So everything's done through multi-sim now rather than 2 separate pieces of software, which is awesome. And again, like I said, this is gonna take some time. And it's telling you what it's doing while it's doing it. And if you look down here at the bottom where it says echo is off, echo is off, echo is off, echo is off, ha ha ha, very funny joke. So echo is off, okay? And it's gonna start running through, and you'll see, okay, it's telling you about Xilinx 86 to 22, all rights reserved, and it's slowly going to program this thing. Now, as this goes through, we're looking for 2 things at the end of this, okay? There are warnings, which are okay, and then there are errors. Errors are what we do not want to see. So if this thing is programming, and like I said, this is going to take some time, right? We're not talking about 10 or 15 minutes, but it still isn't super fast. And it's going through. None of this is going to make sense to you because it doesn't make sense to me, okay? This is just code that's going through that's kind of letting you know that, yeah, it is going. It's working. It's doing its thing here. It's just taking time. So we'll see what happens at the end. Okay, this actually worked, which is like never, ever actually happens. Now let me show how you know. Number one, at the bottom of this, errors, 0, warnings, 0. Now that took 2 minutes and 4 seconds to upload. So again, kind of slow when you're just sitting waiting for it, right? 2 minutes seems like an eternity. But here's how you know it absolutely worked. When you look at your chip, you're going to see a blue light is now lit. Everybody see the little blue light there? So red power light, yellow ready light, but the blue light indicates that the program is successfully uploaded. So now it's on me as to whether or not this thing actually is wired correctly, because that's the other obstacle that you may face. You may have hooked the wires up wrong, or you might not have hooked them up well, okay? So let's just see, I'm just going to readjust the camera here. Down at the bottom are my switches. You can't really see them that well, but here's switch 0 and switch 1, and what should happen is, oh yeah, look at that. When I do switch 0, see the green light? Right here, everybody see my finger, right? The green light comes down. We got all, it's like Christmas lights here. We got all the lights going. So there's the green light. Switch 1 should light it up. Sure does. And both of them together should also light it up. That's an OR gate circuit, okay? So all I had to do was some programming. I had to wait for the Xilinx to connect. It took 2 minutes. I did 3 wires, 2 inputs, 1 output, and there you have it. The only time the OR gate is off is when they are both off. So 0, 0. So that's 0, 0. That's 0, 1. That's 1, 0. And that's 1, 1. And that's what it's supposed to do. So again, this is an individual thing. Mainly what I'm concerned with is not you hooking this up necessarily. There's 3 wires here. It's not that big of a deal. But can you make the PLD file, and can you get it to upload to the chip and get this to function? Again, there's my green LED letting me know that the OR gate is in fact functioning. So there you have it. That's what you're supposed to do. Obviously, again, if you're going to build the fireplace circuit, so let's say you get through level 1 of this, the next level up is level 2, where you're going to build the fireplace circuit. You really should be working with your partner on that. However, if your partner is light years behind you, which could be the case, I will allow you to build the fireplace circuit separately, and then you'll have to build it. And of course, like I said, fireplace circuit requires 4 inputs and 2 outputs in order to function. So that would mean a total of 4 wires need to be added to this particular setup. And of course, you'd also have to upload the PLD logic circuit that you're going to have to construct. Now people are like, hey Mr. V, can't we just copy the sim circuit over to PLD? Nope. Nope. Simulation circuit is basically la la land. Some of those things don't exist, okay? But the PLD circuit is real. Those are actual real gates and connections you're going to use. These programs do not see the same things. So no, you cannot convert PLD to SIM, and you can't convert SIM to PLD. You must redesign the circuit in PLD and program this properly. Won't work otherwise, right? It doesn't work. We've tried it. I've had the shortcut students, the ones that like to go, 900 miles an hour and everything. They've tried it. Doesn't work, right? You have to build it from scratch, starting from the foundation up. All right, so there you go. That's how this is supposed to work. I'm going to go ahead and cut off the video at this point.